Hello everyone, welcome to StudyIQ. In the previous video, what we have seen is the questions related to factorials, right? So we have seen the different questions which can be asked from the concept of factorials. What do you mean by factorials? It's actually product of numbers, product of consecutive numbers starting from 1. Okay, so if it is 3 factorial, 1 into 2 into 3, like that. And then what are the possible questions from factorials that we have discussed? What is the highest power of a number in a factorial? One question. Then we have discussed about number of zeros in a factorial. Then we have discussed about number of factors of a factorial. Now here in this session, what we are going to do is, we are going to discuss about sum of first n consecutive natural numbers. In the previous session, if it was product of first n consecutive natural numbers, here we are going to look at sum. So it's like 1 plus 2 plus 3. So this is sum of first 3 natural numbers. We write it as sigma 3. So what about sigma 4? 1 plus 2 plus 3 plus 4. Okay, so basically sum of first 4 natural numbers. Then we will see the questions which is related to this particular pattern. Very important and very interesting, and you may get very difficult questions also, but I'll make it very simple so that you can solve it when it comes to any aptitude exam. So you can get sigma n questions from the lower level and to the higher level. I'll solve 2-3 higher level questions also here. Okay, so let's understand what do you mean by sigma n. Okay, or let's understand sigma n numbers. So the first number will be like 1. There is nothing to add. 0 plus 1. Okay, or 1, it's like that. Next sigma n number is actually 3. What is this? It's actually 1 plus 2. Next number will be 1 plus 2 plus 3. So that is 6. Next number will be 1 plus 2 plus 3 plus 4. So that is 10. So fourth number means you will add 1, 2, 3, 4. Fifth will be 1, 2, 3, 4, 5. That will be 15. Sixth will be 1, 2, 3, 4, 5, 6 you need to add. So 21. Like this it will go. So these are the sigma n numbers. 1, 3, 6, 10, 15, 21, etc. We also call these numbers as triangular numbers. Triangular numbers. Why we call this as triangular number is basically because you can visualize or you can represent these numbers as triangles. Okay, see, 3 you can represent like this. Okay, you get a triangle, or you can represent like this also. Okay, so the second one is a right angle triangle. Similarly, 6 you can represent like this. 6 if you want, you can represent like this also. That's actually a triangle, right? So the second one is actually the right angle triangle. Okay, so this is 3, this is 6. So what about 10? 10 if you need to represent, it's like this. So this is also a triangle. Or what if you need to make a right angle triangle, it will be like this. So you got a right angle triangle. Okay, so you can visualize or you can represent this as a triangle. That's why it is called as triangular numbers. So sigma n numbers are also called as triangular numbers. Now, one of the interesting speciality of triangular number, let's take two triangular number, 1 and 3. You add this, you get 4, which is a square number. Similarly, 3 and 6 if you take, you add, you get 9. So two consecutive triangular numbers if you add, you get square numbers, right? 10, 15, you get 25. 15, 21, you get 36. All these are square numbers. Now why you are getting square? Because two triangles, when you join them, you get a square. Okay, see, what is a square? Square, if you see, this is a square, right? It's actually two triangles. Two triangles form a square. Now, if you ask me where is two triangles in 4, I can show you. It's like this. Let's take the first, so 4 is actually 1 plus 3. So 3, I can take like this. This is 3. Then 1, join, you get a square. So that's what 4. Then, so these are the numbers, right? 1, 3, 6, 10, 15, 21, etc. So adding them will give you square number. 4, 9, 16, 25, 36. These are square numbers. So 4 you have already seen the representation, right? So it's actually 3 plus 1. So 3 and 1, right? So you need a 3. So I'll take this 3 like this and I need 1. So I get 4. Then if you see here, 3 and 6 will give you 9. So let's take the 6 first. Okay, 1. Now I got 6. I need to add 3, right? So what you need to do is take the 3. Okay, you have a 3 here, right? Take this 3 and flip it over and make it upside down, and after that you can place it here. Okay, like this, you get a square. Similarly, if you observe here 10 and 16, this one also I'll show you. After that, this is very simple, right? 10 and 16 will give you square. Let's take 10 first. Let's take 10. Okay, now let's take 6. Okay, and add them together. So 6 means you have a 6 here, right? This is 6. So make it upside down, flip it over. So you can mark it as like this. So you got a square. Now I hope this is clear for all of you. So two triangular numbers, if you add, you get a square number. And based on this, some patterns and interesting questions are coming. That's why I'm discussing it. It's not just like drawing something. Okay. So I'm going to discuss in depth about this concept in the coming 20 minutes. Okay, so I hope this is clear for all of you. I hope all of you understood what is sigma n or triangular number and how you are actually getting a square number. You are adding two triangles or you are adding two triangular number, you get a square number. And I hope you visualized it completely. Now, what we need is a formula or a generalization for sigma n, right? So if I tell you sum of first 10 terms, you must be in a position to write. You can't just count like 1 plus 2 plus 3 plus 4 plus up to 10. You need a formula, right? Then this is going to be very easy. And you have a formula that is n into n plus 1 divided by 2. So this is actually the formula of sigma n. If n terms are there, you need to find sigma n. What does this mean? Sum of first n consecutive natural numbers, n into n plus 1 by 2. Now why you are getting this formula, I tell you. The reason is, okay, so let's take sum of 10 terms. So this is sigma 10 will be 10 into 11 divided by 2, right? 10 into 11 divided by 2. Now, how you got this formula? If you remember, I have already discussed with you AP, okay, the concepts and everything we have discussed about arithmetic progression and geometric progression. And AP, from AP, we can understand this formula. Because when we discussed about AP, I have told you sum to n terms. If you remember, I have given formula for sum to n terms, two formulas. So, sum to n terms I have given as n by 2 into 2a plus n minus 1 into d. This is one formula, and the second one or the easiest one which I have given you is n by 2 into first term plus last term, right? First term plus last term. Okay, now let's forget about the first formula. I am going to apply the second formula because we know the first term and last term in this case, right? See, actually sum of first 10 natural numbers. So anyway, natural numbers will make an AP. We know that. So first 10 natural number means 1, 2, 3, 4, 5, 6 up to 10. So we know this is an AP. What they're actually asking you is sum of this AP. That's what sum of first 10 natural numbers, right? So what is the first term? 1. What is the last term? That is 10. So this bracket is filled, right? Then n by 2. N by 2 means 10 by 2 because 10 terms are there. And that's what you got here, 10 by 2. That's what this 10 by 2. Okay, this 10 by 2 and this 10 by 2 and this 11 and this 11. Okay, so actually this 11 how you are getting, or why you are getting this n plus 1 is basically because 1 is the first term, n is the last term. 1 is the first term, n is the last term. So that's what the formula. 1 is the first term and last term is n. So we know first term as 1, last term as n, because you need to find sum of n terms, right? Then this n you already know, that is nothing but n itself, that number of that term itself, right? Here it was 10 and divided by 2. So that's why you are simplifying sigma n as n into n plus 1 divided by 2. So if you understand this from AP point of view, you can write it as sum of n, which is nothing but sigma n itself, is equal to n by 2 into first term, that is 1 itself, plus last term, that is nothing but n itself. So this is a formula, or easily n into n plus 1 divided by 2. This is how you'll understand this formula. Now let's see the questions. Okay, so I hope you understood about sigma n. Now let's see the questions. I give you a pattern question here. So you have a pattern which is given 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, etc. So you have got a series. Okay, you need to find the 288th term. Okay, now this was the actual question. So if you want, you can get 289 term, 300 term, 312 term, 325 term, whatever it is, we are going to solve it. Okay, we will solve for 288 and we get the answer for everything. Now instead of 1 2 2 3 3 3 3 4 4 4 4 etc., the actual question which was actually A comma B comma B, C comma C comma C, D D D D. This was the question and 288 term is what asked. Okay, but let's understand it in a number. Then after that we can, anyway answer is same. Okay, so answer is same, so we'll come to that. So let's find 288 term of this series. 1 2 2 3 3 3 4 4 4 4. Let's understand the speciality of this series. See, this is the first term, okay, and second term and third term is 2. So this is first term, this is third term. Now 3 means this is sixth term, this is sixth term, okay, that is sixth term, and this is 10th term. Okay, so if you observe here 1 3 6 10, what is that number? What is the speciality? These are sigma n number. What are sigma n number? 1 3 6 10 15 21 etc. We have seen this, right? So these are sigma n number. Now how you understand this series? See, sigma, what is 3? 3 is actually sigma 2. 3 is sigma 2, 1 plus 2. So sigma second term is 2 and previous 2 terms are 2. Sigma second term, that means third term is 2, previous 2 terms is 2. Now here if you see 6 is nothing but sigma 3. So sigma 3 is 3, okay, and previous 3 is 3. Now here if you observe, this is nothing but sigma 4. Sigma 4 is 4 and previous 4 is 4. So what about 15th term? 15 is sigma 5, so it will be 5 and previous 5 will be 5. So 11, 12, 13, 14, 15 term will be 5. 16, 17, 18, 19, 20, 20, 21 will be 6 because sigma 6 is 21, previous 6 will be 21. Sigma 7 will be 28, previous 7 will be 28. That means 22nd, 23rd, 24th, 25, 26, 27, 28 will be 7. So what we need to find is 288th term. 288 term. So what we need is actually the nearest sigma n number to 288. 288 is not a sigma n number. We need to find the nearest sigma n number. Now will you find it? See, what is sigma n? Sigma n is actually n into n plus 1 divided by 2. Okay. Now let's take this 2 here. So 2 times sigma n is equal to n into n plus 1. Now compared to n plus 1 will be small, so I can approximate this as n square. So 2 times sigma n will give you n square. Just an approximation to find this answer. Now these steps are not required from here onwards, just for understanding. And this is what you are going to use in most of the sigma n questions. So 2 times sigma n I can approximate to sigma n square. 2 times sigma n I can approximate to n square. So I need to find a sigma n number close to 288. So take 2 times, so assume that this is sigma n, but it's not actually sigma n. Let's find the nearest sigma n number. So take 2 times of it. What is that? 576. Okay, so we know 576 is equal to n square or approximately equal to n square. So what is n? N is equal to 24. So approximate number of term is what I am getting. So n is equal to 24. Now let's find the sigma 24. Okay, so what is sigma 24? Sigma 24 is actually 24 into 25 divided by 2. 24 into 25 divided by 2. So let's cancel this out. You get 12. So what you get is 300. Okay, so sigma 24 is 300. What does this mean? 300 term will be 24. Why? Sigma 24 is 300 and sigma 24 term will be 24. Previous 24 terms will be 24. That's what we understood from this pattern, right? Sigma second term will be 2, previous 2 is 2. That's what we understood here. Sigma 3 is 3, previous 3 is 3. Here sigma 4 is 4, previous 4 is 4. So sigma 24 will be 24, previous 24 will be 24. So sigma 24 is what? That is nothing but 300. So 300 term will be 24, previous 24 terms will be 24. That means 277, 278, 279, 280, 281, 282 up to 300 term will be 24. 24 terms are 24. And what is asked is 288 term. Obviously, this will be 24. Because 300 term is 24, previous 24 will be 24. So instead of 288, if I ask you 280, still it is 24. If I ask you 285, that is also 24. If I ask you 290, that is also 24. 291, 292, 295, 297, 299, 300 for that matter, 24. If I ask you 301th term, 301 term, that will be 25. That will be 25. Why? Because, so what is the condition? Let's take sigma 25. Sigma 25 is 25 into 26 divided by 2. Okay, so this is getting cancelled out and you get 325. What does this mean? Sigma 25 is 325. So sigma 25th term, that is 325th term will be 25. Previous 25 will be 25. That means 301 to 325 will be 25. I can ask you any from this: 301, 302, 303, 312, 313, 314, 324, 325 will be 25. Okay, so what I can conclude now from this 277 to 300, what will be the answer? 24. Be it any term from this, answer is 24. 301 to 325 will be 25. 325 to 326 to 351 will be 26, because sigma 26 is 351 and previous 26 will be 26. I hope you understood this, right? Now let me give you the previous question which I have discussed. Instead of 1, 2, 3, I put A, B, B, C, 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 D, 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 etc. This is same. Answer is same. If it was a number, you get 24 as the answer. Now, instead of 1 it is A, instead of 2 it is B, instead of 3 it is C, instead of 4 it is D. So instead of 24, what will be the answer? X. So if 277 to 300, if the question, answer is X. 301 to 325, answer is Y. 326 to 351, answer is Z. I hope this is clear for all of you. Now smaller number also they can ask you. What is let's say they can ask you 150th term also, so you can find the answer based on that. I hope this is clear for all of you. Now another interesting pattern you can see in case of sigma and numbers are, let's take these numbers 0, 1, 3, 6, 10, 15, right? These are sigma and numbers. These are called as triangular numbers also. Now let's square these numbers. 0 is nothing but 0, 1 is 1 itself, okay? Then 3 square is 9, 6 square 36, 10 square 100, 15 square 225. Okay, now let's take the difference. So here 1 minus 0, 1, okay, 9 minus 1, 8, 36 minus 9, 27, 100 minus 36, 64, 225 minus 100, 125. Now if you look at this, what is the speciality? These are nothing but cube numbers. Okay, so the difference of the square of triangular numbers will give you cube numbers. Now how will you get questions based on sigma n? Okay, let's make a question and we will solve it. Obviously you will understand it in a much better way, right? Now let's take any sigma n number. Let's take the sigma 20. Okay, so sigma 20. So what is sigma 20? 20 into 21 divided by 2. So this is nothing but 210. Is nothing but 210. Okay. Now imagine how to make a question. Imagine you have a book. Okay. So you need to make a question based on the book. It's like the page numbers will be mentioned in the book 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. Okay. So the way you make a question is something like this. This is a classical example. So a lot of questions are asked from the same pattern repeatedly. So the person is counting the page numbers of a book, okay, and while counting he added a page. Okay, so if 20 pages are there in the book, okay, what you are supposed to get? You are supposed to get 210. 210 is the correct answer because we know 20 pages, this is the sum, okay. But while adding the pages, he added one page extra. Okay, he added one page extra and he got something like 222. He got 222. The question will be what page he missed out. What is your answer? 222 minus 210. So 12 is your answer. How can you answer this as 12? If you know 210 is the original, then you can answer which page number he double counted. So which page number he double counted? That is 12. How can you get it? What is given in the question is he got 222 and you know you are supposed to get 210. For that you should know that the page numbers are 20, which is not given. So if you can find 210, then answer is ready, right? So how will you get that number? See, this kind of question, if you can mug up all the sigma n values, then the answer is very easy, right? You can just find the nearest sigma n number to this. He is adding a page, so the previous sigma n number, if you can mug up, if you can remember that is 210, the answer is 12, the difference. But I don't think it is possible to remember all the sigma n number. Instead of 222, they can ask you 1024 also. So they can ask you bigger numbers. So it is not worth remembering all these numbers. If you can remember, that's the best method. In 10 seconds, you can solve it. Okay, nobody can stop you. If you don't remember, only for those students, I am discussing this method. This is also going to be very easy for you. So what we need to find this number, original number. Then we can get the answer faster. Now how will you find the original number is the question. So nearest sigma n number to 222, which is less than 222. Why we need to find less than 222? Because we are adding a page. If you are missing a page, we will see the next sigma n number, right? So if you remember just now, I have already told you 2 times sigma n is actually n square. Those who missed out, it's like sigma n is equal to n into n plus 1. So divided by 2, sigma n 2 times is equal to n into n plus 1. So n compared to n, 1 is very small. So you can approximately write sigma n 2 times is equal to n square. And we are going to use this concept here. Okay. So what is given? You got 222. What is the question? You are counting the page numbers and you double counted a page. You got 222. Nothing is given. Number of pages, actual sum, nothing is given. What is given is this much only. You are counting the page numbers. You double counted a page. You got 222. You realize that it is wrong. Which page number you double counted? Nothing else is given. Only one number, that is 222. Another information, you are double counting. One page. Okay. So 222 is what? You are trying to find out sigma n, but mistakenly you got 222 by adding one page. This is actually a number which is close to a sigma n number. So we need to find the nearest sigma n number and take the difference. Okay. So we know 2 times sigma n is equal to n square. Okay. So this is, you assume that for time being, you assume that this is sigma n number, because he is trying to find sigma n. What is 2 times of it? What is 2 times of it? 444, right? So what you got? 2 times sigma n is what you got? 444. So 2 times sigma n, you got 444, which is nothing but n square. Which is nothing but n square. So if you take root of it, you will get what? N. Once you get n, what is that? That is the page number of the book. Okay. So what is square root of 444? You know this will be between 21 and 22, because 21 square is 441, 22 square is 484. Okay. Now you take 21 as your n. Okay. So assume that 21 is your n. Why you are see, you can take any one of this. You are taking 21 because you are double counting. So when you are double counting, you take it on the lower side. So what is your actual sigma n? 21 into 22 divided by 2. So this is 11. Now 21 into 11 means 21. That is nothing but 231. So here the problem is, when you are taking 21 as the number of pages, we already know that is 20. So I am not touching that. So when you are taking 21 as the number of pages, you are actually getting sigma n as 231. That is contradictory, because original sigma n is 231 if page numbers are 21. Okay, but when he is doing, he is getting 222 even after adding one page. That means you understood 21 is not the page number. So let me take 20. Okay, so let me take 20. Assume that 20 is the page number. So let's find sigma n then. 20 into 21 divided by 2. So you get 210. So from this you understood that the nearest sigma n is actually 210. Then what you got is actually 222. So the difference is 12 and your answer is 12. Which page number you double counted? 12. Since we discussed about sigma n, I also want to discuss about sigma n square. This is nothing but 1 square plus 2 square plus 3 square plus 4 square, etc. Sum of squares. Okay. So you have a formula, n into n plus 1 into 2n plus 1 divided by 6. N into n plus 1 into 2n plus 1 divided by 6. So you can get questions like this. I will come to I will discuss about these examples in the or when we solve the questions. Okay, so the questions are like this. One person A, he came and he wrote, let's say, numbers like 1 2 3 4 5 6 etc. Another person came and he wrote these numbers 2 3 4 5 6 etc. Another person came and he wrote 3 4 5 6 etc. Another person who came and write 4 5 6 etc. So what is the total sum of numbers involved in board? Okay, so this is actually 1, this is actually 2 square, this is actually 3 square, this is actually 4 square. So this is actually sum of squares. So what you need to do, you need to find sigma n square. We will discuss about similar questions when we solve the questions. I am just discussing the concept now. Okay, so sigma n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Similarly, sigma n cube is equal to, we already know what is sigma n, right? So sigma n is n into n plus 1 divided by 2. Take square of it, sigma n cube. What is sigma n cube? 1 cube plus 2 cube plus 3 cube etc etc etc. So cubes of first n natural numbers, that is what sigma n cube. Square of first n natural number, that is sigma n square. Sum of first n natural number, that is what sigma n. If you want, I give you applications of sigma n square and sigma n cube which used to come in exams. Let's take a square. Okay, let's take a 2 into 2 square. So if I ask you how many squares are there in this, okay, you will tell me this is 1 2 3 4 and the bigger one, so total 5 squares are there. Okay, and how you got this 5? If I ask you, you can visualize or you can answer it as 1 square plus 2 square. Why up to 2 square only? Is because it is 2 into 2 square. So if it is a 2 into 2 square, number of squares will be 1 square plus 2 square. If it was a 3 into 3 square, then 1 square plus 2 square plus 3 square. Okay, so if it was a 3 into 3 square, your answer is 1 square plus 2 square plus 3 square. So this is nothing but sigma n square only. And that's why you need to know the formula of sigma n square. Now here also you can manually find, right? So 1 square is 1, 2 square is 4, 3 square is 9. So you can get the answer easily. 13 plus 1, 14. But if I ask you some number of squares in a chessboard, if I ask you number of squares in a chessboard, then you know chessboard is 8 into 8 square. So your answer is 1 square plus 2 square plus etc etc up to 8 square. It's not worth finding manually during exam. So you can apply the formula n into n plus 1 into 2n plus 1 divided by 6. We have discussed. Now in case of chessboard, what is n? N is 8. So 8 into 9 into 2 times 8, 16 plus 1, 17 divided by 6. You get the answer, right? So this is getting cancelled out. So this become 4, this become 3 and 3. So 17 into 12 will give you 204. Now onwards you don't want to do even this also. The moment you get a question, how many squares are there in a chessboard? 204. But if they give you a question like this, a chessboard is designed such that it's a 7 into 7 square, then you need to solve it like this. Or just like 7 into 7 square, they give you how many squares are there, then you apply this formula. So number of squares in a n into n square is actually sum of squares. 1 square, 2 square, 3 square, 4 square up to n square. And n can be anything. 4 into 4 square means 1 square, 2 square, 3 square, 4 square. If it is 10 into 10 square, 1 square, 2 square, 3 square up to 10 square. Now instead of square, if I ask you rectangle, how many rectangles are there in this? Now one more thing which you need to know is square is a rectangle. Square is actually a special case of a rectangle. So rectangle is nothing but you have all 4 angles are 90 and this 2 and this 2 are equal. Okay, square is also satisfying the conditions. This 2 and this 2 all are equal and all 4s are 90. So square is also a rectangle. So 1, 2, 3, 4 rectangles. Then after that you can get this rectangle. You can get this rectangle. So 6. Then you can get this as rectangle. Then you can get this as rectangle. So you got 8. Then the bigger square is also another rectangle, 9. So number of rectangles, if you see, it's 9. Now if I ask you why you got this 9, you will tell me 1 cube plus 2 cube. This is higher level of understanding. So 1 cube plus 2 cube, you got 9. So if I ask you number of rectangles, you will find sum of cubes. If it is 2 into 2 square, 1 cube plus 2 cube. If it is 3 into 3 square, 1 cube plus 2 cube plus 3 cube. If I ask you number of rectangles in a chessboard, you will find 1 cube plus 2 cube plus 3 cube up to 8 cube. What is this? Number of rectangles in a chessboard. You will find cubes. If I ask you squares, number of squares in a rectangle, you will find squares. 1 square, 2 square, 3 square, etc. 8 square. And you know the formula for this? Sigma n cube is equal to n into n plus 1 divided by 2 whole square. You know the formula for this? Sigma n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Let's see number of rectangles in a 8 into 8 square. So what is the formula? 8 into 9 divided by 2 square. So there is nothing but 36 square. That is nothing but 1296. 1296. So now onwards, if someone is asking you number of squares in a square, 8 into 8 square, 204. Number of rectangles, 1296. So I hope this is clear for all of you. So if I give you n into n square, if I ask you number of squares in this, what is your answer? Sigma n square. If I ask you number of rectangles in this n into n square, what is your answer? Sigma n cube. You know what is sigma n square, right? N into n plus 1 into 2n plus 1 divided by 6. You know what is sigma n cube? N into n plus 1 by 2 raised to 2. What is n? That depends on this given square, n into n square. If 8 into 8 square means n is 8. If 4 into 4 square means n is 4. If 5 into 5 square means n is 5. Just substitute and get the answer. Don't think too much. You don't try to count also.